In this lesson, we will discuss the fundamentals of the Cisco Meraki MS switch platform. To help build your understanding of the Meraki MS switch platform, let's explore how Cisco Meraki has redefined the management and configuration of switches. The MS switch portfolio includes numerous models, scaling from access to campus aggregation, with features including cloud-managed physical stacking, multi-gigabit performance, and Universal Power over Ethernet (UPoE) on the campus network. Let's take a closer look at some of the other features included in the MS platform. The quality behind 150 milliseconds is often unacceptable for supporting voice and video traffic. Cisco Meraki switches support Layer 2 and Layer 3 quality of service, ensuring these real-time traffic flows are given priority as they enter and traverse the network. Set the switch port to accept Ingress Prioritization label, or for a certain port's chosen priority level. 6 queues with 4 QoS settings support flexible policy implementation. Layer 7 application visibility, that was previously only available through costly overlay appliances, is included in Cisco Meraki switches at no additional cost. Hundreds of applications are automatically identified and reported, applications from Business App to BitTorrent and YouTube. Rather than separately managing each switch, switches can be grouped together in virtual stacks, regardless of how physically dispersed those switches may be. For high performance and management convenience, switches can also be physically stacked together and managed as a single entity. OSPF routing automatically factors in link costs to calculate the optimal pathway for routing packet from point A to point B. This efficient transmit tool improves network performance since delays across slow links are minimized. Network ports are all around us. Most are physically secure deployments, but many are not. Using 802.1x port-based network access control, MAC-based identification, or a mix of the two, the network administration can lock down access on a port-by-port basis to authorize users or devices. Guest VLAN can be configured to provide restricted access to the Internet via DMZ or a remediation server. We will discuss 2 additional features, cable test and packet capture, later in this lesson. Let's have a look at the current MS switch models. The MS220 are EOS-EOL. The migration path and current generation is the MS120 family. The MS128 is a compact switch that is fanless and provides 8 gigabit Ethernet ports and 2 fiber SFP uplinks. It is also capable of delivering multiple ports PoE plus power with the integrated power supply. The MS120 is also available in a 1-rack unit form factor with a variety of switch port and power configurations available, as well as power redundancy through utilizing a Cisco RPS 2300 unit. The MS210 and MS225 are both frequently seen positioned as stackable access switches for branch and small campuses. They both come with a selection of 24 or 48 port configurations and power supplies for different PoE needs. They both feature the ability to physically stack in a ring that has 80 G of stacking bandwidth in the backplane. The MS210 as well as the MS225 are both capable of performing static routing. The MS210 has 4 1 gigabit SFP uplinks, while the MS225 has 4 10 gigabit SFP plus uplinks. The MS250 and MS350 can be considered our stackable high-performance switches because of their innate ability to perform dynamic L3 routing. The MS250 is very similar to the MS225, except for their differences in routing abilities and their power supply configurations. The MS410 is an SFP and SFP Plus only switch and has 2 dedicated stacking ports for a total of 160 gigabits of stacking bandwidth. The MS425 is an SFP Plus only and has two 40 gigabit QSFP Plus uplinks and has the ability to do flexible stacking. Note, there is a specific restriction with regards to stacking. Only like models can be stacked. For example, an MS350-48 and an MS350-24X can be stacked. However, the MS250-48 cannot be stacked with the MS350-48. Physical stacking is available on the MS225, 250, 350, and 410, which includes a dedicated second port. Flexible stacking is available on the MS425 switches, which do not have a dedicated stacking port. Any port on these switches can be configured as stack ports. Gigabit connections have served us well for many years. They bring fast, low-latency data to the PCs, phones, and other devices sitting on our desks. With rapid advances in wireless technology, the latest generation of access points can overwhelm any gigabit connection. Thus, the wired network becomes a performance bottleneck. With the continuing trend of wireless as the dominant medium, a technology was needed that could push past the long-standing 1 gigabit limit. Multi-gigabit is the technology capable of delivering up to 10 gigabits per second to the most demanding IT equipment. 10 gigabit speed and even faster have been available over copper cabling for some time. However, these options are limited, either by the need for short cable runs or the need to use the very latest twisted pair cable type, Cat5e, Cat6a, or higher. For many organizations, the cost of ripping out and upgrading cable outweighs the benefits. So, Cat5e and Cat6 remain the prevailing copper technology installed today. Multi-gigabit technology bridges a gap between 1 and 10 gigabit standards, adding options for 2.5 and 5 gigabits over existing cabling. Multi-gigabit technology is the collaborative work of the N-based T Alliance, a consortium of over 45 industry leaders from 2014. This effort has combined into an emerging IEEE standard, 802.3bz, which formally introduced 2.5 gigabit-based T and 5 gigabit-based T in 2016. The design is an addition to the Meraki MS350 flagship Layer 3 stackable access switch family. The MS350-24X has 24 ports, 8 of which are multi-gig capable and can support speeds of 1, 2.5, 5, and 10 gigabits on supported cable types. This switch perfectly complements the MR53 and MR84, which are multi-gig capable. Managing switches is an essential part of network administration. With that in mind, the Cisco Meraki MS solution portfolio does not include expensive features or require you pay for support licenses. There are no requirements for proprietary cables either. Large networks can be assembled using a combination of standalone, physically stacked, and aggregation layer switches. Resiliency is supported in hardware and software with hot-swappable power supplies and fans, plus link aggregation and warm spare functionality. MS switches can be stacked up to 8 stacked switches per wiring closet, all of which are managed through a single pane of glass, the Meraki dashboard. The dedicated stacking cable between switches in the stack provides up to 160 gigabits of stack bandwidth with spatial reuse and link up to the core distribution layer. By using cross-stack LACP, throughput between network layers is maximized and all links are forwarding. Virtual stacking is a concept pioneered by Cisco Meraki. MS series switches can be treated as a virtual stack without requiring a physical connection and regardless of their location. This means that switches can be in different physical locations. For instance, you might have one switch in New York and another switch in California, and administrators in yet a third location have unprecedented visibility and manageability in all the ports of the virtual stack. This greatly simplifies management of large distributed networks. Switches that are in the same physical location can be physically stacked and managed using virtual stacking in the same way. You can leverage the power of centralized cloud management to pre-stage switches in the virtual stack before they are even deployed. Using this approach, switch deployment becomes a zero-touch, plug-and-play exercise, even by non-technical staff. Bug changes and software updates are straightforward to push out, eliminating the requirement to be physically present at each switch or stack. Network topology automatically maps network architecture, showing how Meraki security, switches, cameras, and wireless devices are connected, including redundant links disabled by the spanning tree protocol to prevent data loops. In the topology view, a square represents MX security appliances, a rectangle represents MS switches, and a circle represents MR access points. Non-Meraki equipment is also detected and displayed. Because Meraki MS switches automatically seeks for LADP and CDP broadcasts from connected devices, it may be possible to detect the manufacturer, model type, IP address, and more from third-party equipment. This is done automatically. There is no overlay software needed. Quickly zero in on a device that matters by using the dynamic search tool available in the topology dashboard view. You can search for a network device by name, type, or device type to see how equipment is deployed. Devices not meeting search criteria will be automatically dimmed, so that search for equipment is highlighted. Conversely, if you are viewing detail for a specific client, like a laptop or a mobile phone from within the Meraki dashboard, clicking the topology link will highlight which network device that client is directly connected to, enabling a quick assessment of upstream connectivity. See at a glance where trouble lies on your network. Devices displayed in the topology view are color-coded based on connectivity health. Cisco Meraki devices that are displayed in red or yellow can be immediately clicked into for remote diagnosis and troubleshooting. Hovering over individual network links displays the active port of each termination point, the number of clients using that link for the last day, link speed, and link usage. These statistics make it easy to pinpoint which links are the most heavily trafficked and service the most clients. The Cisco Meraki MS platform offers troubleshooting features that allow administrators to resolve network problems efficiently and effectively. Every network engineer knows that sooner or later, only a packet capture will truly identify the source of the network problem. Cisco Meraki offers the unique ability to run a detailed packet capture from anywhere with an internet connection without needing to be directly connected to the router or switch. Simply select the port or the device in Dashboard and run the capture. This will generate an industry-standard PCAP file, which can be opened with the usual software. Many Internet network issues start at the physical layer. At a remote site, a cable connecting to a computer or a remote phone may become damaged or may not be usable. With built-in remote cable testing, the network administrator can test the integrity of the cable even thousands of miles away. A cable test will also indicate the approximate length of the cable, helping the remote engineer understand whether he is working on a patch cable or a building cable.